talk about Splunk. That's today's topic. So if you go to samsclass.info and click this Network Security Monitoring with Splunk, you end up here. And I've got 2 Splunk servers with the data already loaded in it and everything you can just use, so you don't have to install anything. So open up one of these, and they have a password, a username of student1 and a password of student1, which is of course not very secure, but the only point is to stop automated attacks from taking them down all the time. Now, Splunk has a limitation that you can only view data for the last 5 years. And I couldn't figure out how to turn that off, so I just turned the clock on my server back a few years. That's why you get that warning. So the data appears, because this is archived data. This is data created by Splunk for training purposes. And so you see about 1 million events from 7 years ago. This is Boss of the SOC is an annual capture the flag competition that Splunk puts out, and then they make it open source and publish the data so anybody can use it. And that's what I'm using here. I'm using the first Boss of the SOC, which is in my opinion, the best. So you can use Splunk. Now the point of Splunk is it is Google for log data. That's why the interface itself is very simple and very easy to use. All the complexity and difficulty of Splunk is from the nature of the log data itself. The logs of Windows and other products are kind of hard to understand and search through. That's the problem. So the first thing is to understand what kind of data you have, and you go to the search tool, which is the default. The only thing we're going to use is the default search tool, and the data summary will show you an overall summary of what kind of data we have, this 1 million plus events. So, should be coming up. There it comes. All right. The first one sorts it by the name of the host, which is probably useful if it's your company and you know what the names of the servers are. But for me, the most useful is source types. And here you see the kind of data you have. You have Windows event logs. There's a lot of those. And what's going on here is in Splunk, you configure all of the devices on your network, the servers, the routers, the firewalls, whatever you've got, to forward their logs over the network to a central server and that's what Splunk is. Splunk is just searching all that log data that's been forwarded by every device. And there's a Splunk forwarder for every kind of product you can buy, and there's a community writing it for all the other products. And so you have various things. Now, Sysmon is an optional add-on to Windows, which takes the Windows event logs and makes it into a much simpler log that has a small number of possible events, like about 12 or 13, that are extremely useful, like file open, registry key created, file created, process started, much easier to understand and use. So that's what these Sysmon events are. Then you have some FortiGate logs, FGT, from FortiGate Firewall. Then you've got IIS, that's from the Microsoft Web Server logs. Then there's some Nessus logs. I'm not really sure what that's about. Nessus is a volume scanner. There's just a few events there. There are some stream logs. Splunk can monitor the network traffic directly, and then it doesn't record full packet captures, but it records a summary of communications, like a stream. Yeah, they're not from Cisco, but it is like Cisco's NetFlow. It's similar. And we'll use the HTTP one quite a bit. It records the complete HTTP request and response, one log entry for each conversation there. So, and their various protocols are here. And then you got Suricata, which is an open source intrusion detection system. So these will be alerts of identified malicious activity. And then a syslog, which I think is mostly from the Splunk server itself. All right, so that's the type of data we have. And so, let me go to my plan here. I think we start with HTTP. Yeah. Now, you can normally in a real server, you specify an index. You sort your log data into categories, like this location, and you break it up into indices. Here we don't really need this. Everything here is the same index bots v1. Now, but if we do that, we'll get all the results on the whole server. So I might as well do that for starters. If I specify nothing but the index and search, then I'm going to get nothing. Well, I'm surprised I got some. This means somebody turned on sampling briefly. But the reason I got almost nothing is because by default it only searches for the last 24 hours, and my server apparently thinks it's 2019. So you really have to change it to all time, because the data we really care about is that data from 7 years ago. Now, it's going to take a long time to do this. The time it takes Splunk to run grows with the number of results. So if you're doing one, this is going to have 1 million results and take quite a while. So that's not really very helpful. So I'm going to turn on event sampling and do 1 in 100. So now it will just do a random 1% of the results, so I can get an overview. And that makes it much faster. And this is what you do when you're exploring something new, just trying to get an idea of what the data is like. So I have 11,000 events when there's 1.1 million. So if you scroll down, you can just look at the log entries one by one here and see what they are, and you can expand them here. And this one is not clear to me actually what the heck this is at all. Source type is A. These are some weird things. I think some student must have created this. By the way, I should mention this. Splunk is very expensive. You have to pay by the amount of data you ingest. But for teaching purposes, you can run Splunk for free as long as you look at archive data and you're not monitoring a large amount of live data. And the free version has all the features, which is what we're using here, but the one feature it doesn't have is the ability to make non-administrator accounts. So everybody is logged in as the database administrator all the time, which means everybody can mess it up. And I thought this is brilliant. This means you can have classes where you train people and you really have the full-featured product, and you can analyze as much archive data as you want, but in order to punish you, your students can totally mess up the server. They're administrator, so they can do weird things they shouldn't do. And that's a very good punishment. That means you couldn't really use it in production, but you can totally use it in class. And of course, looks like people have messed up my server a little bit, but it doesn't matter. A little bit of junk data is normal to wade through. So you can weed through events one by one here, and that is extremely inefficient, just like looking at packets one by one in Wireshark is. You only do that once you get it down to like 5 or 10 interesting packets. What's better is to look at these fields over here. You can choose a field. And so, for example, if I look at source type here and click on that, I can see the various source types here. And if I want to do, say, HTTP, I could take a stream IP here and click on that. That will add it to the query and run it again. And if I want to do HTTP, I could just correct this to HTTP. So you can just type queries up there if you want to. But I find it easier to choose with the mouse and then modify them a little to make sure I get the punctuation right and all that. So this will give me HTTP events on the server. And now there's a lot fewer of them, 26, but remember I'm only looking at 1/100th of them now. So now I can probably turn off the sampling. And now I'm getting, I think I'll get like 17,000 of them. Let's see. 3,000. All right. So I'm getting HTTP events. And as I said, here's what HTTP events look like. You have a client IP address, and here's the, looks like the destination, looks like some kind of Microsoft certificate coming down. Here's the headers, 200 OK. And here's the source headers. So you sent this HTTP GET to a Microsoft server, and you got this reply from the Microsoft server that is largely binary data, and so on. So let me go back to my plan here. All right, there's talked about source types. So we look at stream HTTP events. All right. So with 1 in 100, we should have had 200 events. I'm a little concerned that I'm only finding 3,000. This makes me wonder if I'm going to have to change the clock on my server. I wonder if it's cutting some of them out. We'll see. No, the good stuff is in 2016, and my server seems to think it's 2019, so I should be okay. I might have to restore this server from a backup or something. I'm a little concerned. We'll see if I don't find the good stuff. If not, I have a second server we can use. So anyway, what I want to do is look at HTTP events for the name of our web server. And this is they made a company with this domain name, I'mReallyNotBatman.com. So if you add that to the query, it will look for that. Now you can put just a word here like you might in Google, and then it will just look for that word anywhere in the event. The Splunk purists don't like this. I do this all the time. This is the easy way to use Splunk, like Google. The purists don't like it because it consumes more CPU. It's more efficient to give it fields equals value, but you can also just search for a value here, and this is just like using grep to look through logs. Yeah, creating and using indexes does optimize the query and speeds up the searches, right. Zebedee is correct. So using these indexes and using this kind of query is the fastest, most efficient way to use Splunk. But if you don't care about speed, you can just put in search terms, and then you're just looking for that word anywhere in the event, just like you could with grep, and you can get the job done that way. So here, all right, this time I found 251 events, but that was a sampling of 1 to 100. Now I've turned off the sampling, and I'm only finding 1331 events, which troubles me. But anyway, if you look down here, something about a document has moved. And if I look at the source headers, this document may be found. Here's a big binary thing being sent. There's Joomla, downloading a big page from Joomla. And I'm looking, there we are. There's the source headers making the request. All right. Let me try my other server, because I have a feeling this server is not giving me the best answers. The other server is splunk2.samsclass.info. Let's see if this one gives me the expected results. All right. We go to search. Wonder if someone's been messing my servers up. Let me get the stream is HTTP. And
Good question.
Yeah.
Is everybody in Twitch?
What's that?
Everybody is in Twitch? Is it working?
I hope so. Yeah. Twitch should be working. I can see your Twitch is not working.
No.
Oh, that's weird. Why don't you share your screen? Let's see what's happening. It's no fun if you can't see it. Just try refreshing the browser. It looks okay here. Are the people able to see it in Twitch? It's working for Melissa. Okay.
If it is working for one, then it's my problem. I'll restart. Thank you.
Yeah. Try restarting. All right. That's no fun. All right. Or use a different browser. Someone says it was.
That's a good idea. I'll start. Okay.
Yeah.
Thank you. Sorry.
Well,
Sorry to disturb.
that's fine. Okay, good. Most people would say it works. Yep, good. Well, I'm glad you told me. Certainly it's no fun without the pictures. Anyway, I'm just having to catch up and try my other server. Anyway, so what you're missing now is not too exciting. Let's see if this is going to work on the other server. I want to go to all time. Okay. And search. Let's see if I find the right number of events here. Yeah, now I'm finding 15,000 events, 22,000 events. That's more like it. Okay, the second server seems to be fine. After this demo, I will restore the first server from backup. I think it's somehow been messed up. All right. I logged into both servers, but I didn't do anything when I saw this weird icons. Couldn't even find yes. Yeah, I'm not sure there is a log out option. Like I say, you're stuck in the administrator account all the time with this demo version. All right, so let me put in I'm really not Batman here. All right, that should give me the web requests to their web server. That domain name would not appear in any request going to another server. And I have no sampling, so I'll see all the events. And when I did it before, I found 251 at 1 in 100, so I should see something like 25,000. Oh, there we are, 22,000. This looks good. Okay, now I want to see these as a list, not a table. There, then I can see the fields here. And if I scroll down, I'm looking at the requests here. And this is what I was looking for. Very soon, you should easily find this, some packets coming from the AtruNetworks vulnerability scanner. And this is a commercial vulnerability scanner. So what's going on, of course, is most of this is attack traffic. What they did was set up a corporate network with several servers and then run various attacks against it, and we're analyzing the logs to find those attacks. And one of the things they did was scan it with a commercial vulnerability scanner called Acunetics. And if you have the Acunetics scanner, by default, it puts these header fields in to mark the traffic so everybody will know what scanner is doing this. So from this, once you find one of these, you can now answer a whole series of flags. If you look at this, the first few flags are, what is the name of the scanner? Well, you can see the name of the scanner there. The next one is, what is the attacker's IP and the web server's IP? And these are things you'll need later. So I'm going to open a text file and take notes. Okay, so attacker IP and web server IP. All right, so for that, this is requests that came from the Acunetics scanner against the web server, so the source IP is the attacker's IP, this number starting with 40. So I can save that, we'll need it later. And the destination is going to be the web server IP. So there it is, starting with 192, that's the IP of the server. So there's a few flags there. Now that you've got that information, now we can find some interesting stuff here. We're going to find the name of the file used to deface the web server. These people logged onto the server, they managed to get the ability to execute code on the server, and they downloaded a file and defaced the web server. And to do this, this is where you first see the power of Splunk. I've got 1 million events, but I'm going to find the events that go backwards through the network. Now, I'm looking at HTTP events here, and if I look at the client IP down here, here's client IP. There are 2 client IPs. These are 2 people that have viewed the web server in this traffic, in this time. Now, the web server's IP address does not appear here because it's not the source. The web server is not the source, it's the destination of these requests. However, and this, by the way, is the way a network should be set up. You should configure your firewalls and routers to control traffic flow, so your server should be only a server. You don't want anybody opening a browser and surfing the web from your web server. There's 2 reasons for that. In the first place, they might get it infected with malware. But in the second place, and more importantly, this is what the attackers do. They get control of your server, and then they open a reverse shell where they will reach out from the server out to an attacker-controlled server to exfiltrate data and when it gets infected, and you don't want to allow that. So your server should not be allowed to initiate any outgoing connections. That should be forbidden, and I want to see if that ever happened. So I'm going to put in a client IP here by clicking on this, and then I'm going to change that to be the web server's IP address that I found. So I'm looking for traffic, HTTP requests that originated directly from the web server. This should not be possible. I mean, it should not be allowed by a properly configured network. And right now, I find 0 events, which might seem good, but remember, I left the domain name in here. And of course, if somebody was making an outgoing connection from the web server, it would not have that web server's domain name in it. So I need to remove that. This is traffic going backwards through the network that shouldn't be allowed. And there are a very small number of events where this happened, and this is suspicious traffic going the wrong way through the network. There's 9 such events. And if you look at these events, you can see it is malicious traffic. Here's a bunch of binary data being downloaded, and here's an image being downloaded, and you can see the path right there. That's the name of the file used to deface the server. Poison Ivy is coming for you, Batman. So that's obviously the malicious image being downloaded. That's the file name, and you can find the domain name from the staging server. You can see that they've in fact connected. Here's a GET request, loading that, and it's getting it from this strange domain name here on a strange port number, jumpingcrab.com on port 1337. So this is the suspicious domain name that's used to host the malicious image they're downloading, which is quite common. So that's the first bit of stuff to do here. There's 4 stages of this, but that's the first attack you analyze. And I'm going to stop this video and let people do it.